Hi everybody, Professor Jim here. Working on algebra. Now we're going to advance over to the distributive rule. Just like exponents are called exponents, powers, or degrees, they have three different names for the same thing. The rules, laws, and properties are three names for the same thing. You can call it any of the three. It all means that you're going to wind up taking a term or a number on the outside of a bracket and multiplying it by what's inside the bracket. Okay, so we'll work on distributive rule. I like calling it rule. All right. So our number on the outside, or our term on the outside, is a 9. Okay, easy enough. We take the 9 and we multiply it by each term inside the bracket. Okay, so 9 times 5 is 45. And that's matched up with an x, so we keep the x okay. 9 times minus 3 will be minus 27. Second distributive rule that we have, 3 times 10x will be 30x. 3 times 2 will be 6. Okay, now we collect like terms. Previous video, we talked about like terms. They have the same variable, the same exponent. Okay, these are x's with a 1 for an exponent. We don't have to write down the 1. So we'll add up the numbers. 45 and 30 will give us 75. And we keep our x. Minus 27 and 6 are numbers. We put them together. 6 minus 27, or minus 27 plus 6, whichever way you want to add them or subtract them, comes out to negative 21. So that would be our answer. We collected our like terms. Sometimes what people like doing is putting all the like terms together and then collecting. They collect them like that. So let's do that too. We can do that. Do what I call a rewrite. I don't know if that's in any math books or not. I have no idea. But it works. So, hey, as long as it works, it's good. Okay. So I just rewrote it. I put the x's together. I put the numbers together. And then we can just easily collect them. This will be our 75x. We get the same answer. And we get minus 21. Okay, so that's distributive rule. There could be 5 terms in here. Each term, let's talk about terms for a second. Or actually more than a second. Each term can have 3 parts. Obviously the numbers by themselves don't have 3 parts. But when they start having an unknown, they have 3 parts. They have the coefficient, which we've seen before. We have the variable, not variance, that's statistics. They have the variable, this is algebra. And they have the exponent. When we did 5x equals 20 in an earlier video, we could have put the exponent of 1 on the x, but we didn't have to. The 1 is understood. Okay. All right, so those are the parts of the term. So it's got 3 parts. Coefficients are a number that matches up with our unknown, and then sometimes there's an exponent. We do area, length times width. We have an exponent. We're not going to do that word problem right now, but there's word problems that use exponents. We have to go factor, which we didn't get to yet. That's a little further down the line in algebra. But we're going to be using them eventually. Okay, so we've got our distributive rule in place, and we've got our terms in place. Okay, let's take our distributive rule and let's look at something called an inequality. An inequality, something that's not equal. Something's bigger than something, called greater than, something smaller than something, or less than. Can be greater than or equal to, can be less than or equal to. All right, let's, for demo's sake, let's take a look at what we have. All right. Okay, let's look at something like this. This will combine distributive rule and inequalities together. Okay? And then we're going to go look at a number line. First we'll do this, we'll put it on a number line, and that'll be that for this video. Okay. Number on the outside, or term on the outside, times each term on the inside. Okay, 15x okay. This is totally unscripted, so hopefully everything will work out right. Okay, let's see what we have. Now we're going to do what I call juggling. You won't see that in any math book. We're going to move terms between the left side and the right side and solve for x. Except this time we're not solving for x, we're seeing if x is greater than or equal to something. Okay, so this time we don't have an equality. It's not x equals 3, x equals 17. It'll be x is greater than or less than a number. Okay, let's see what we have. Now to move things from one side to the other, we do the opposite. If we're here we're adding, so instead of adding, we do subtracting. All right. Opposite of adding, subtracting, opposite of multiplying is dividing. All right. So we'll take the 14x from the right side and we're going to move it to the left side. So we'll make it minus 14x. That will get rid of it on the right side. Keep everything in balance. Okay. 15x minus 14x, 1x, or just x. Okay, so far so good. Now we'll do the same thing with the numbers. 27 is positive, we'll make it minus 27 on the left. We have to balance it and make it minus 27 on the right. X is now greater than 3. Okay, x is positive, we want to solve for a positive unknown, positive variable. If we wound up with a negative x, that would be the same as minus 1x, and we would divide, the minus 1 would be the coefficient, we divide each side by minus 1. And if we did that, the sign would flip the other direction. We'll do that on the next video. Okay, so we have x is greater than 3. Wonderful. Number line. 0 in the middle, infinity all the way on the right, negative infinity all the way on the left. For those of you with my math lab, they don't like circles that are filled in or not filled in. They like brackets. Okay, so let's do both. So if you have my math lab, we'll do my math lab first with brackets. Okay. Greater than, less than. They use rounded brackets. Okay. If it's included, if the number's included, if it's greater than or equal to or less than or equal to, they use these squared off brackets. Okay. In this case, we have x is greater than 3, so we'll show that on a number line. All right. 1, 2, 3. 3 is not included because it's bigger than 3. It could be 3 point a million zeros and a 1. That is officially bigger than 3. So 3 is not included. So for my math lab purposes, we would use a rounded bracket, and we'd show which direction it's going. Is 10 greater than You know, if x was 10, would that be greater than 3? Yes. If it was 5, yes. So we're going to the right. Greater than goes right. Less than goes left. Less than and left start with the same first two letters. So if there's one of them that you have to remember less than and left. Okay. All right, so in this case, rounded bracket. Okay, x is greater than 3. Everything's good. That's our number line. And thanks for watching this video. In the next video, we'll be working on greater than and equal to. Thanks.